Um, so let me start with this graph. There are different components that we have used in our program, and all those components that you see there from A to D have been added to the precision planter. But for convenience aspects, reasons, we have used precision planting components because we can all those be interfaced with the 2020 display that you see in the center. But one key message for me to provide in this slide is to tell you that for A, B, and C, those can be set up to be in a variable rate mode, meaning that they can be adjusted on the go. And we are focused on getting that type of information so that we can provide recommendations on how to do it, right? So for D, what's interesting is that is a feedback loop that we are finding very interesting with a lot of potential. And I'll explain more about this particular feedback sensors. Now, in 2020, so what I'm speaking today is strongly connected with what we did in 2020, last year. So this is just an image of that. We were exploring heavily on this function of controlling the downward force. So last year, we installed a hydraulic system that can do that. The advantage is that that's a system that can react in both directions, either going up, going down, increase or decrease the force, the downward force that is sensed on the gauge wheels. So you see the image on the left, you see one of the two gauge wheels, and in red, you see this pin. In this case, it is an instrumented pin. It is a force transducer and has all the components and connection to the 2020 display. So you can see on the right that there is this image of the 2020 display from 0 to 240. Those were values that we set on that display. So it was under our control. This is one of the treatments, or one of the factors in this two-way factorial. Second factor was how we prepared the beds. We were aiming at wet planting. So how much pressure can we add, or what is the right level of soil consolidation that will have an impact on germination and emergence of cotton, but the other is on future development. Okay, so you see there that we set 4 different levels of soil compaction, but those were, even though I call them just by names, from compacted to loose soil, those were quantified. So what we found last year, the very first thing to notice is that there were no differences in stain counts. With all the control that we have, with all the detail that we put in these plantings, with, again, it was enabled singulation, we were hitting for a particular population, all those elements work well. So the end result is that as far as counting the number of seedlings, there were no differences. But very substantial differences were found in the timing of the emergence and the seedling development. So that's our focus from this point on. How do we evaluate it last year? And with this image, I'm going to go very superficial, but on the picture on the left, it's telling you something about how we can measure the vigor, the response of a plant to light. And the higher the amount of light that is reflected means that there was less light that was absorbed by the plant. Since plants use light for photosynthesis, a high reflectance means a poor plant, or a plant that is not up to good in a comparison to a good level of development. And the opposite is true. A a plant that's reflecting less light because it's using it for growth means it's a larger and better developed plant. So you see in this picture here on the right that we have two sensors that we use for this evaluation. So we are only monitoring 2 rows out of the 4. And this is a good picture to show you that this particular plot, 4-row plot that we're looking into, has plants that are much larger than the adjacent plots. So sorry, I didn't have a good picture to show what I just said, but from some angle you can see here that these plants are different than those to the on the side. And with that, after 46 days after planting, we got this survey that show us that the best plant development, seeding development, is happening when we add 90 pounds of force during the planting process. So there were many other things that we measured, and now we were ready for year 2, that's 2021. So in 2021, we retrofitted our planter with a depth control, seeding depth control system. So you can see here in these pictures that there's where you usually have a lever and you select that depth position. In this case, it's an electric motor. It's an actuator that it simply does the same function, but many advantages are in this system. One is that it happens automatically and very fast. The other is it doesn't go in discrete points as the points of the lever indicate, right? And you see some detail there in the picture on the far right, where the slots where you position the levers are still visible, but there's no lever. Everything is controlled by this motor. And again, that is controlled with the 2020 display. 4 treatments we selected this year for planting depth, from 3/4 of an inch to 1 inch and 3/4. So it's only an inch difference between the shallowest and the deepest one, but major differences are in the response. So you can see by the position of the seed firmware how these different depths were created. Now, let me briefly mention a few of the results and observations. The first is really an observation that uniformity in seed depth, it is outstanding. I don't work for precision planting, but I was really impressed to every time that we evaluated the depth, the actual depth that seed was deposited, it was very consistent in a straight line. But also we notice how strong the gradient is in soil moisture, because it's an irony that we can have tons of moisture everywhere in the bed, but where we need it, that is in the top of the bed, in the center. But this picture showed you some of that. Lots of moisture down, but where these seeds were deposited, the soil wasn't as wet as we need it to be. Okay, second observation, it is a little more technical, but this picture I think shows what I'm referring to. In this picture, those were seeds that were planted 1 inch and 3/4 and still made it up. Some fat chunks were observed, but they still made it up and with very good populations. But I want you to see in this picture is actually the wall next to those seedlings. And that is created by the for the opening discs as they cut the soil, move the soil to the side, and then the closing wheels come and put pressure on it. And in this case, with the moisture that we have at that level, that soil doesn't break, doesn't crumble. What it does is that it collapses. It's a different way of failure, which is not ideal. These plants were struggling to go up because there are big chunks in their way. Now, then the other element that we were testing this year in 2021 is the instrumented firmware. The picture on the right tells you that there is these lights there. That simply indicates that there is the sensor is active. There are different windows in this unit, and it's measuring different characteristics. And seeing the lights only means that it's active. But let me show you the data that we can generate with that type of system. So the instrumented firmware, we did some work in Yuma, Arizona, just to get preliminary observations. And for this audience that's cotton oriented, I think there are two important parameters. That is soil temperature and moisture content. Because early planting, which is the best timing for planting cotton, also gets into issues of the right temperature and the right moisture content. So with this system, we can measure that, and potentially a solution that can be derived is to have a response system that will be looking for the right temperature, the right depth within certain parameters, of course. Some results from preliminary from this 2021 season. It is in terms of soil moisture, we get a reading that it was expected. The deeper we go, the higher the moisture content. And in this case, we have about 4 percent points of difference. Again, this is happening at a time. This is happening at a time when the soil is it's in late May season, so it's different. Related point is the sensor output on soil temp. Again, the shallower you are, the warmer the soil is, and those are the trends that we found on that during that planting time. And there's a mistake there. When this is 16 days after planting, it shouldn't be there. So just ignore the 16 days after planting. Okay. This slide only, the objective is only to show you that there is information generated at the time of planting, and potentially that can be used for a more smart system to look for the right conditions. Now it is a seedling assessment 16 days after planting. And we use the same method of using sensors and measure the light reflectance. So in this case, you see on the left, what is the response of seedlings that were planted 3/4 of an inch versus 1.5 inches, and that's the plot on the right. Very different responses. Scales are the same for both plots, but there is a delay in emergence for the shallower planting. So that will clearly have an effect. In the end, what we are after is to increase efficiency in our planting systems, and that's not an ideal situation. We want fast emergence and complete. So the last topic that I want to touch is it's only looking into future trends with some present information. Okay, so this particular slide is referring to the pesticide application at the time of planting. This is an existing system called the Smart Box by ANBAC. That's still current. You can still buy this equipment. I have not used it myself, so I don't know how the interface, there are any electronics, any control. I know nothing about it. But you see all the different chemicals that you can use in this system. You buy these containers and you can send them back, and they can be refilled and used multiple times. Now, what I'm getting more information, and this is scheduled to be delivered in 2021, is these systems that are also retrofittable to a existing row unit planter. But in this case, the interface is done through the same display that you use for your auto steer, where there is a John Deere or a Trimble, whatever it is, so you control this function from the cab. So one of the things is variable rate. That can be used for chemicals, either liquid or granular, to be dispensed at different rates depending on where you are, where the machine is in the field. So this looks very promising for some conditions. I have consulted with Peter, Alex, and Randy Norton, and we're talking about how we can implement this in our conditions, Arizona, where we need to improve handling of pesticides or chemicals, and where it makes sense to do it. This is my last slide, and this is mainly an idea. These are existing components from precision planting, and these were developed for liquid injection of fertilizers. That's their main intention. Also controlled from the 2020 display. There are two systems here, and their main difference is where they place that liquid in the soil, whether it is far away from the seed or closer, whether it's 2 lines or 3 lines. Those are the variations, and of course soil types will have a very significant effect on the performance of either one. But here's my thought. Well, if they can inject fertilizer, liquid fertilizer, perhaps we can also adapt them to do some liquid chemicals, liquid herbicides, or liquid pesticides that we can adapt it to our conditions in Arizona. So I look forward to work with the IPM folks and with any grower or PCA interested in doing some of that. I'd love to hear your input for those that are informed in these new options in chemical availability, if you guys know more about it. So thank you for your attention. I don't know, Ayman, are we good on time, or can we answer questions, or let's just wait for it?
We are good in time. If anyone has questions or would like to unmute and ask question for Pedro, that's a good time now. There is also, as I said, all the time there is the chat box, but we have like a minute here. If anybody want to ask a question. Okay.
Well, I'm gonna stick around for the rest of the meeting, and if at some point some questions come, anybody can reach me either directly or through Ayman and Kyle. They will both. I'll work with them. So this is an open invitation for any inquiry in this particular type of technologies.
Good. Thank you, Pedro.
Okay.